so excited to be here part of the next JSConf. My name is Christopher Chedeau. I'm also known as Vjeux on the internet, and today I'm going to talk about Excalidraw. So Excalidraw is a tool called a virtual whiteboard, but in essence it is a way to get all of your thoughts onto paper and communicate with each other. So the way it started was January 1st, 2020. So at Facebook we have this process called peer feedback, where you have to give feedback on the people that you're working with. And this is very important because this is a way for everybody to start learning and growing and being better. Now, I'm a big procrastinator. And so when it happens, I'm basically cannot focus on doing the things I'm supposed to be doing. And I've started using a technique recently called active procrastination. And so what this means is I'm basically know that I'm not going to do the thing I want to do, like peer feedback. And so I'm actually going to focus on something else. And so in this case, what I wanted was to write a blog post. And for the past 10 years, I've been using a tool called Vjeux that makes handwritten diagrams. The unfortunate event is that day, the Vjeux tool wasn't working anymore. And so I was like, maybe I could write it. Doesn't seem super complicated and seems like fun. And so I started using this library called Vjeux in order to make those handwritten lines. And I use Code Sandbox to prototype it. So I put it on Twitter, and much to my surprise, there was a lot of excitement about it. So the next day, I decided to create a GitHub repo and to add the Vjeux integration. So it gave me two things. So the first one is people could actually submit pull requests, and I could see live what it was doing. And so I didn't have to import the pull request, start locally developing it. I could just play around with what they were proposing. It was much easier to get the live collaboration aspect going. The second part is with one click I was able to get a website up and going. So I didn't do DevOps or anything. It was just working. And so with this integration, my goal was to build a community around this, because I'm only one person and I still had this feedback to write. I wrote it, don't worry about it. So what I did was my playbook with all of the previous open source projects I've been running is to create a list of the things I wish the project would have. And so I think I created 20 of them, and a lot of people started contributing. And this was amazing. So a lot of energy, and the project moved really fast. Now, let's talk about all of the nitty-gritty details of how rendering works within Excalidraw. So we are here today at Next.js.conf, which is all about React. And the most fundamental idea of React is that you've got a piece of state, and you're implementing a render function that takes this piece of state and generates an output. And so in the context of Excalidraw, every single time you do a mouse move event within the app, we're going to generate a new piece of state, which is the list of all of the things you're seeing on the screen. So you're going to have rectangles, text, arrows, circles. And then you're going to do some magic that is going to generate how do you render it using this handwritten feeling. First, let's talk about text. The font right now looks handwritten. And this is not a coincidence. Elinor Rapp actually took her handwriting and converted it into a font. And so she did it 20 years ago. The good news is the font is amazing and it really looks handwritten, and I really like the feeling and the look and feel. The challenge is when we started scaling, it didn't support any accentuated characters. So I'm French and I like to do my E accent circumflex, but I couldn't do it in this font. And so I actually reached out to her 20 years later, and she agreed to update the font and add all of the regular accents, and also Cyrillic and Greek character sets. So now this font can be used by a lot more people. And not only this, she also open sourced the font. So you can go on GitHub and actually submit a proposal for improvements of the font. So this is one of the great things about the internet and open source is you can reach to people that have specific skills to make the project better. The second piece about Excalidraw is all of the shapes that you can write. For example, you can do arrows, rectangles, circles, like all of this good stuff. And in practice, you can reduce it down to how do you display a line that looks handwritten. And for this, we use the library called Vjeux. And in a nutshell, the library takes a point A and a point B and gives you a list of operations in order to make it look handwritten. You can look at the website. It has a very in-depth documentation of how the algorithm works, which is super exciting. But this is out of scope for this presentation. So we know the output of this is a list of Bezier curves that we need to draw. And for this, there's two ways to do it in the browser. One is you can send it as an SVG node and let the browser do its things. And the second thing is to use a canvas element, which can draw them and actually give you the pixels. And so this is all of our architecture of Excalidraw. We start with a high-level JSON list of all of the shapes. For the text, we send it to the font. And for the shapes, we deconstruct it into a series of lines that we send to Vjeux to get the list of operation, and we render it. And so you may think, okay, we're doing all of this every single mouse move. It must be slow, no? In practice, with the recent improvement with all of the browsers and all of the machines, you can render like hundreds and low thousands of elements at 60 FPS. And so this is plenty fast for all of the general use cases you're using for Excalidraw. Now, one of the challenges, we started implementing zooming out. And not only this, but people started using Excalidraw like vehemently with the infinite canvas and have like really, really large documents. And so with those two things in mind, we were able to see in practice like tens of thousands of elements, and this started not scaling anymore. And so for this, we implemented one performance improvement, and this is implementing caching. And so caching is a way to trade off memory for CPU. So in this case, what we have done is to store two pieces of information. The first one is from an element high-level description, what are the list of the Bezier paths we need to do? And the second one is from the list of Bezier paths, what is the canvas that's going to be generated. And so we are storing those two things in memory. And now the rendering operation is going to be much faster for the things we already computed. Because now we can just, for every single element in the canvas, if they haven't changed, now we can just get the corresponding canvas element and just do a copy to the final canvas. And doing a copy of like raw bits of memory is the fastest things computer can do. So this is like almost instant. And so this is the thing that we've done with the optimization part in the rendering. Now let's go back to the timeline. So we are in January 2020, and as you all know, 3 months later in March, COVID happened. And everybody was sent home and needed to interact with each other only virtually. And so one of the big aspects around this transition was this kind of like physical whiteboard experience turned out to be actually very relevant into how people were working. And a lot of people started thinking about how do I have the equivalent online. And at that time, a lot of people started looking at Excalidraw in order to be able to do it. And they actually started using it. But there was one big issue facing with this system is that at that point, Excalidraw did not have any multiplayer feature. So you could work on it on your own computer, but you couldn't collaborate with other people. And so one thing that we've done is during this weekend, right after everybody was sent home, a few of us hacked together a multiplayer feature. And this is again like one of the reasons why React is so good, is that if you remember, it's all about taking a piece of state and rendering the UI from it. And so now what we needed was just to take this piece of state and synchronize it with all of the other clients. And if we were able to do this, nothing in the app would change. We would be able to get the live player feature working. So we went into a bit of thinking around like how do you synchronize these states effectively. And one of the systems that we've done is very simple but very effective. So it relies on the fact that in a multiplayer version of a whiteboard, if you are able to see the cursor and like what are other people doing at the same time, you're very unlikely to have two people working on the same piece of diagram together. What's going to happen is you're going to wait that somebody else is going to work with it, and then when they're done, now you can start working on it. And if both of you are really working together, then you can expect as a user that things are not going to work well. And so for this, with this observation in mind, we use a very simple synchronization algorithm, which is to add one piece of information on every single element, which is a version counter. So anytime anybody changes this element, the version counter is increased by 1. And so now, when there's two people working on the same element, for example, changing the size of the element or the background color, and the two versions are being updated, now the one with the highest version is going to win. Now, in practice, if two people are really truly synchronizing at the same time, one thing we can do is to have every single person also generate a random number, and whoever has the highest random number is going to override the other's action. And so with this small trick, now we're able to get the synchronization working. And there's only one other aspect regarding deleting an element. So we're using tombstones. So we're marking the element as being deleted, so that if somebody else synchronizes that the element exists, it doesn't reappear out of nowhere. So with those two setups, we've been able to get the synchronization working. And while it was very simple to implement, in practice it's working extremely well for this particular kind of application. So now that we've seen how multiplayer is working, I want to talk about something else. And this something is, how well do I sleep at night? So now you're probably wondering, why am I talking about this? And so in practice, one of my biggest worry with this is that in this setup, the server actually sees in plain text all of the scenes that people are working on. And not only this, if we implement persistent storage, now the hackers can see all of the scenes being shared like since day one. And one of the tricky challenge with this is, like, this is a side project for me, and I didn't have like the resources, or I didn't was willing to spend the time to actually secure the server and make sure like no mistakes were made. And so in practice, what that meant is I wasn't sleeping well. But the good thing is, I work at Facebook at Meta, and we have one app which is WhatsApp that is fully end-to-end encrypted. And I felt like, oh, this may be interesting for this use case. So what does end-to-end encryption mean? It means that the client is going to like see all of the data, and before sending it to the server, is going to encrypt this data. So like the server only sees like an encrypted blob of things, and is going to send the blob of things to the other clients. And because the different clients are able to exchange like the private keys to read the data, they are both able to read it, but not the server. And so this is the same concept that we implemented with Excalidraw. Now, in a different context, because we're on the web. And so the very much like the very thing that unlocked this for the web is the URL. And one other thing you may not know about for the URL is there's really two parts of this. The first part is the thing that you think about for a URL, like HTTP and like the domain and like after like the slash, like all of those things. And there's also like the hash sign. And one of the very interesting things is that anything that is written after the hash sign is never sent to the server. So what this means is the server, like when you load an URL, like gets everything before the hash sign, the browser gets it, and then sends to the server, hey, please give me the HTML for this part of the URL. Then the server sends back the HTML, and then some JavaScript is being run client-side, and this JavaScript has access to whatever is after the hash sign. And so now we have a system where like the hash sign can be used to store the private key that the server never sees, but all of the clients are able to like see it and share it. And so with this system, we're able to get end-to-end encryption working on the client. The other part that was needed for this is how do you actually encrypt? And for this, there's a new web crypto API that is implemented by all of the browsers now that lets you do all of the cryptographic operations to be able to implement the system. And so thankfully, like the web has all of the primitive needed for the end-to-end encryption. And so now I'm sleeping much better at night knowing that like even if something happens to the server, like none of your data is going to be seen by other people. So far, I've described the architecture of the open source version of Excalidraw, which is hosted on excalidraw.com. Now, one of the main design decisions around it is we don't have the notion of an authenticated user. In practice, every user has their data in the local storage of their browser, and this is how like we make it secure. Now, this adds constraints and challenges. So for example, if you want to share a bunch of different drawings with many different people and finely tune like who has access to what, you can do it, but you're going to do it outside of the system. So you're going to send links to a bunch of people and make sure like they don't see the right links and everything. But this is pretty tedious. And so this is like one of the challenges around this. The second challenge is around the funding model. So in practice, Excalidraw is open source, and we have a way for people to donate to the project. But what we've seen so far is that even though a lot of you actually contributed, and please, we want more contribution, right now the amount that we're receiving through that channel is not even enough to fund like one person working on it full time. And so for those two areas, one of the things that we've decided to do is to actually create a company around Excalidraw, and specifically with a product for SaaS. And so if you think about Google Docs or Figma, you're able to get like all of the files, and you're able to get like all of the fine-grained control of like who sees what. You're also going to be able to get authentication and use your company's authentication. And then one advantage of Excalidraw being a company is now the company can actually like sends like the form request for like third-party authorization. So we can give you like the privacy policy, the security compliance, like all of the audits and all of those kind of things, which as an open source project is really hard to do. And finally, this is able to fund the open source version. So right now, thanks to this, we have like 8 people working full-time on Excalidraw, both the open source version and the SaaS version. So if you're interested in contributing, you can use Excalidraw Plus and pay for the subscription. This is now the sad time where we need to part ways. I really hope that this talk was useful to you, and I want you to leave with 3 takeaways. The first one is the React model is very effective for this kind of application. Having the data being separated from the rendering and from the synchronization meant we could build like all of those 3 pieces independently, and none of them, if there were bugs or design decisions that affected one, would affect the other. The second one is where data lives and who has access to it is very important, and only going to be more so. And I hope to show you that using cryptography and end-to-end encryption, we can change the paradigm, and we can actually make the data more secure for the people. And finally, the open source funding model is something that a lot of people talk about. And I hope to show you that with this Excalidraw Plus SaaS product, there is a way to fund the open source version in a way that's effective and useful for everybody. So thank you, and see you next time.